Welcome to this episode DIY CNC build. In the first episode we will introduce the concept of this really small but fast and rigid machine. Don't be afraid of the size of this machine, but it's engineered to be mobile in a car or get stored on a desk or on a bench in the workshop. All assembly groups are modular and can be easily extended to the necessary size. This is my channel DS Machine Parts, Modern Crafting with Technic and Machines. So, let me introduce the DSM Compact DIY CNC Milling Machine. This is a really small machine engineered for a single product. This machine has a machining area of 210 by 280 by 100 mm or approx 8 by 11 by 4 inches. The product that needs to get machined has a stock dimension of 200 by 200 by 20 mm or approx 8 by 8 by 1 inches. The product is made out of 5083 aluminium. The machine is made for a mobile use in a car or on a desk or bench with normal 230 volts plug. The product is custom and gets machined out of a stock material. As you can see, the stock will mount it on a custom fixture do some screws. There will also be a fixture for preparing the stock material with the bores for clamping, but this is part of a further episode. The custom fixture has a pocket for contour cut the product without cut into the fixture. The fixtures are aligned with pins to be fast and repeatable assembled to the machine. The reference for the fixtures are always the center and the top surface of the fixture. We started with the stock and the fixture to set the maximum travel of the machine. From the stock we go to the next step, engineering the Z-axis. The Z-axis has a travel of 100 mm or approx 4 inches. The spindle is a Marfell FM 1000 WS with a quick tool changer. You can pull on the handle to release the tool, change the tool, and release the handle to clamp the tool. The rails and the ball screw are protected against dust and chips due cover plates. Two standard aluminium profiles will give additional mounting space for equipment like a coolant system. The rails are reference due some machined edges. So this will bring up fast aligning of the rails. We will use a small aluminium round bar and screws for pushing the rails against the machined edges for aligning the rails. The spindle is aligned due 2 pins. So there are 3 parts that needs to get machined. The main plate and 2 side covers. We will see the machining process in a further episode. From the final Z-axis we went over to the XY carrier. This is the XY carrier. This is the connection between the X-axis and the Z-axis. As you can see, there are also some edges for reference the rail carriers. But instead of an aluminium round bar, we will machine a small fixture for pushing the carrier against the edge. After assembly of each carrier, the fixture will be removed. The ball screw supports are reference due pins, and the ball screw is driven by a belt due a NEMA 24 closed loop hybrid servo motor with 3 nanometers. The motor is mounted to a motor mount to the backside of the XY carrier. The XY carrier has also a pocket for mount a small inductive sensor for reference the Z-axis due machining process. To improve the stiffness specially, we will add stiffeners to the backside of the XY carrier. This stiffness is needed to improve the performance due the stock preparing by drilling. So there are 5 parts that needs to get machined. The reference fixture, the main plate, 2 stiffeners, and the motor mount. We will see the machining process in a further episode. Do you also think about why the XY carrier is called XY carrier when it is the connection between the X and Z axis? So it's easy to explain. From a bird view, the XY carrier is part that makes the movement of the X and Y axis. After the XY carrier, we engineered the X-axis, also known as the gantry. The XY carrier is mounted on the rails of the X-axis gantry. This gantry is based on a massive main plate. This main plate has reference edges for the rails, pinholes for locating the ball screw supports, and a pocket for the inductive sensor like at the XY carrier. The main plate is aligned to the 2 side plates and mounted to 2 CNC machined aluminium profiles. The ball screw is also driven by a belt due a NEMA 24 closed loop hybrid servo motor with 3 nanometers. To give the gantry more stiffness, there are 2 big brackets underneath the main plate. The side plates has also some threads for mount some dust and chip brush covers. The rail carriers for the Y-axis are also aligned by a machined edge and get pushed against the edges due some aluminium round bars. Both sidewalls are connected to a strut aluminium profile. This profile is also CNC machined to length to prevent a bending of the gantry. The ball screw nut mount is supported by a small bracket. The gantry is the connection between the XY carrier and the Y-axis. So there are 7 parts that need to get machined. The main plate, 2 side plates, 3 aluminum profiles and the ball screw nut mount bracket. We will see the machining process in a further episode. From the final X-axis gantry we will go forward with the engineering process of the Y-axis. This is the Y-axis, mainly the base of the whole machine. The core of this axis is a big aluminum plate. There are machined edges for reference the rail mounting brackets and pinholes for locating the ball screw supports. The rail brackets gets referenced by aluminum rounds. The same for the rails. The ball screw is driven by a coupler direct to a NEMA 24 closed loop hybrid servo motor with 3 nanometers. The motor is mounted to a bracket to the main plate. The Y-axis has also a pocket for an inductive sensor for reference the gantry do machining process. The Y-axis are mounted 2 small brackets to aluminum profiles to the enclosure of the machine. On the top side of the main plate we will machine 2 holes for fixture locating and 9 threads for fixture mounting. There is also a bigger bore for a simple tool length sensor. So there are 4 parts that need to get machined. The main plate, 2 rail brackets and the motor mount. We will see the machining process in a further episode. The whole machine needs an enclosure to prevent chips gets outside and can hurt anyone. The enclosure is made out of different aluminum profiles and acryl and metal covers. There are 2 chip bended metal plates for bring the chips into a small drawer. The controller and all the electric for the sensors, the motors and the spindle is located on a controller base plate in the bottom of the enclosure. In the front cover will be some buttons for reference, start, pause, stop and park position. In the side cover will be some pugs for power connection. So this is how the complete machine will looks like. I think there will be some changes due some engineering problems while we build the machine. But we will give some details on this changes when we make them. For the machining process we will need a lot of fixtures, setups and G-codes. So we will work with Fusion 360 to engineer these fixtures and to create these setups and G-codes. All parts will get machined on my own DIY CNC milling machine. Complete we have some aluminum profiles that needs to get machined to length and a small fixture mounted to my machine table. Then we have a lot of parts that needs to get machined in the vise and some bigger parts that needs to get machined on a custom fixture. You can find some parts I use as an affiliate link down in the description. So I hope you like this concept and maybe you can take some details of this build for your build. Please leave a subscription, give this video a thumb up and give me a comment how about you like this concept. You can also give me a comment if you have some input for me or found some mistake I make do the engineering process of this build. I hope you enjoy this episode. I would be proud if you leave a comment and a thumb up. You can be sure, the next video will also be awesome, so stay connected with a subscription. See you soon.